That's great.
Okay, good. My
Oh,
name is Cecil Bayona, and I have many interests. Among them is all retro hardware. I'm particularly fond of the Motorola 68,000 systems, and I have a board I bought. Actually, I have several I bought, and it's this board called CB030, and CB stands for Cecil Bayona. Uh, 030 is because it's 68,030 CPU. And here's a picture of the board. It's a pretty nice board that I got a steal on it because the guy who created this board needed encouragement. So I encouraged him all the time to make and finish this board. So he gave me a prototype, and I also paid him in advance to kind of sort of obligate him to make the board. And finally, to my surprise, when the board was in the final round, he gave me a second board. So I have two of them. Now, it's an interesting board. Motorola 68,030 running at 24 megahertz. FPGA to take care of all the I/O. You notice there's no um, TTL logic anywhere. It's all handled by this Altera CPLD. We have a boot code in this serial EEPROM, a serial port, a second serial port. It's hard to see here, but it's one of those old-fashioned 72-pin memory sticks. The particular board I'm using right now has 16 megabytes. The other board has 64 megabytes. This is a serial board, and this is an expansion port. One card in case you need a parallel port or something bizarre, okay? So it's a pretty nice board. I got both boards for 50 bucks. That's a pretty good deal. Um, the web page, I posted it, talks about it, the features on it. It can hold up to 128 megs of RAM. Now, for those not familiar with Forth, 128 megabytes is a humongous amount of memory. Forth itself doesn't need a whole lot of memory. The Forth I'm going to be demonstrating only uses 29 kilobytes of memory. The rest is for your programs. So the board comes with CPM for Windows for 68 processor. It has the one I have has a 256 megabyte flash card. That is the disk for the system. So it's very fast. And let's get to it and take a look at the board. There's a web page on it that tells you all the good stuff on it. I posted the link. Now I use in Windows TerraTerm. If I hit the reset button, she comes up. It's a little monitor. And if I tell it to boot, bingo, you missed it. CPM 1.3 just booted. Drive A with just bare minimum to boot. Drive B with a lot more stuff. Drive C with minimal OS software and some on FORTH2020. And the D drive, we have the same thing. And I explain to you in a second. And the E drive is the entire enchilada. CPM68 comes with an assembler, a linker, a librarian, a C compiler. The C compiler is more akin to a small C. It's not a complete C, but it's plenty there to get in trouble. It doesn't have things like structures and whatever. It doesn't matter. So if I go to the C drive and run F83, there it is. Fourth 83 uh, standard of 1983, 2.1.0, which is the latest version that was released, and your typical force thing. Oops. Oh. Okay. Why is this thing misbehaving? You know, gazillion words. Now, I have two versions of Forth loaded in that machine. And the reason is if you'll see a bunch of words up here in the beginning, define, hold on, I must be in the wrong place. Where am I? This one is Forth as it comes out of the box. It has approximately 1,000 words. Words to do with integers, double integers, floats, and your typical force things. Compiler, it comes with a meta compiler. So you can compile F83 and modify it. For example, F83 for 68 was originally FORTH2020 for 8086. And it got modified, the meta compiler, and bingo, it generates a system for the 68,000, and that's where we are. So right now, I have a couple of little sample programs. For example, a multiplication table, and this is the vanilla version of 468, 80, yeah, 68. So it doesn't have it. So how do I work with inputting programs? Well, it has a force editor that I really haven't become familiar with because one, I didn't use CPM for very long. I moved on to CDOS and then to Chromix, which is a Unix based operating system that had every feature you could dream of. And so I used only CPM for a short period of time. And so one of the ways I can, for example, multiply. Here's a program to multiply, to generate a multiplication table. And you saw that on FORTH2020 recently. So I just enter it into a file. And I can go over here. And it says, you want to paste that? Yeah, I want to paste that. Now I have delays put in because the interface the guy created does not have handshake with the hardware. So I put delays between characters and I'm on a character turn, so the system has time to process it. So if I say now mult, it knows what mult is, which is multiply a table 12 by 12 and all the values in between. Okay. Now, one of the features of this Forth is that it has a way of saving. If I remember now, the word. Uh, hmm. It just saved a copy of FORTH83 with a multiplication table built in. So generally, when developing software, I do it bottom up, like a lot of people do with Forth. Bottom up meaning you work on the little tiny details first. How to talk to an I/O port, how to send something to the screen. The real simple stuff. You get it debugged and working. You save the system with all that loaded in it, and from then on, when you reboot, that stuff that works, it's already preloaded into the system, and I don't have to re-enter it again. Okay. So if I exit and I go to the C drive, um, this Forth, I did that too. And as you can see, multiplication is already in there, and I haven't done a thing. So it's kind of handy. A lot of Forths have that feature that you can save a system with all the newly loaded definitions. So I have a couple of programs I loaded in there. For example, print E. E to 100 digits. It calculates it on the fly. And if we look at it, where are we? Uh, there's the code for E. It's a little complicated. There are some routines to print stuff and whatever. And it's built in. What else do I have built in? Uh, this is my own little program that I often used to see how fast a force talks to the system and print, because a lot of the applications I like to do are text based. So printing speed is important to me. So if I go and enter a number and I say test, there we go. Printing the alphabet, including punctuation and everything, upper, lowercase, 100 times. So what else is in there? Civ, the Civ program. You give it a number, how big to go. You tell it to run the Civ. And what it does, it looks for prime numbers from 1 all the way to the number I gave it. And here's a bunch of prime numbers. Now, how do I know it's a prime number? For people who don't know what a prime number is a number that can be derived by multiplying 1 by itself. There's no other combination of numbers that can be multiplied together to generate that number. So, for example, 8087 is a prime number. Okay. So, I have, if I enter 8087 and run a little word that I enter called factors, it says 8087. You can arrive at that by multiplying 8087 times 1. It's a prime number. If I try 8088, that's not a prime number. So what's it going to do? It says you can multiply 8088 by 1 or 4044 by 2 or 202696 by 3 and so on. There's a whole bunch of ways of arriving at that number. It's not a prime number. A prime number can only be arrived at by itself and 1 being multiplied. That's it. Nothing else is passes the test. So it's very straightforward. So if I exit here, well, I don't have to exit. How do I program in Forth? Very simple. Forth lets you, as you've seen, expand the language by adding features. And by the way, this is strictly for beginners because all you guys who have used Forth for years know all of this. You can define words and then save the system, and then those words are there to help you out. So, for example, if I want to print the alphabet, colon tells Forth to define a word, and it's going to be called alpha. Oops, it helps if you spell. And we're going to do loop going through the alphabet. So from 127 from 32, that's the printable alphabet, do a do loop. Now, what are we going to do inside this do loop? I gets the index of the loop. We're at 32, we're at 33, we're at 34 as it loops around. Emit the character to the screen, close the loop, close the definition. I just did a very simple definition that if I type that word, that code will execute. And there she is, the alphabet. I can look at it. It has a primitive, it's indirect threaded, fourth. And so there's a literal 127, it goes into the stack. A literal 32 goes into the stack. It executes for do. It remembers those two numbers. I gets the index, emit sends the character to the screen, loop loops around back to the do. If we haven't hit the target condition, the target condition is that I reaches 127 and get out of town. Okay. A semicolon is the end of the definition, and the system's happy with what it did. So it's a very nice language for interacting with hardware. I started getting interested in Forth. I was a hardware engineer, and I needed something to be able to test hardware to see that it was working correctly as designed. So with Forth, I could write little programs to uh, test the hardware and tell me whether it's working or not, show me whether it's working or not. So in a company I work with, we made CNC equipment. I would design hardware and do a little programming, and I would do all the diagnostics. And I did it all in Forth, and it saved a ton of memory. But here we are. So CPM is an interesting OS. Is extremely primitive. I was looking yesterday through the list of uh, of commands. Oops, I'm already out. For example, uh, if I do a directory, do you notice something? There's no subdirectories. It has a sort of kludge called users. So I'm in the C drive. So if I say I'm user one, okay, 1C, I'm in the C drive. If I do a directory, there's nothing there because I haven't put anything there. That's how you group uh, collections of code and not have a directory that has, 2,000 entries. Uh, so it's very primitive that way, but it's kind of handy. Um, this is the status on the system. I have 4 drives that map to that flash card. And there's 4 drives that are 7K, and some of them got stuff in them. 7, not K, but 7 megabytes each. Uh, so here we are. I'm not sure about the future because I want to work with this card more and the 68,000. It already has a set of tools of CPM, which makes me happy. Um, by the way, how am I doing on time? I forgot to start my clock.
Cecil,
Yeah.
we are out of time. I'm the
Okay.
next.
So I'll terminate it there. The future is either use CPM or go bare metal with a Forth, and that has its advantages because Forth is easily modifiable. And the alternative is there's Unix available for the system. And so I don't know yet what I'm going to do, but it's a pretty nice machine and I'm pretty happy with it and it runs pretty fast. Thank you.
Yeah, thank you very much. Maybe there are some questions. So, yeah, thank you very much. I appreciate some guys still using F83. I'm a big fan of F83, used it for a long time in the 80s. Yeah, right. And I collected different versions of F83 on my GitHub account. So if you're looking for the 68,000 version or the CPM80 version or the MS-DOS version, then you can find them all in the single repository.